Hey guys, so we are going to take a look at vectors today and resolving vectors into their perpendicular components. So take for example, I have a grid here and we have identified 2 points A and B. So let's consider the vector quantity of displacement. So if I want to get from point A to B and I can only travel in straight lines, what are my options? Okay, well, I can go straight from A to B. So we can do that. What other options do I have knowing that I can only travel in straight lines? Okay, well, I can travel horizontally 3 spaces. And then I can go vertically 4 spaces, right? And that will achieve the same result of me reaching from A to B. I can also go first vertically 4 spaces up and then 3 spaces horizontally across, and that would still also take me from A to B. And so we realize that this vector of displacement representing, reaching from A to B can be broken up into a horizontal component and a vertical component. It didn't really matter if I did the horizontal first or if I did the vertical first, but both of these together would be equivalent to the diagonal or this primary vector of getting from A to B. So let's look at this vector here, and let's switch to force. Let's pretend that it's a vector of F, and I want to break this vector up into horizontal and vertical components. But why? Well, because when you deal with everything being in strictly horizontal and strictly vertical, it's a lot easier than if you had to consider, this vector is acting at some angle theta right now. But if I gave you 2 vectors and told you, you had 8 newtons acting to the right and 2 newtons acting to the left, you could do that in your head. You know that the resultant would be 6 newtons to the right. So dealing with purely horizontal and purely vertical tends to be easier. So whenever you're dealing now with vectors that are at an angle, if we are able to split them up into horizontal and vertical components, it's just easier for us, and that's what we're going to get into. And the way to do that is using basic trigonometry, and it's really easy to do. So if we made this vector, because if you look at it over here, we formed a triangle and we identified that, these 2 sides, which are at right angles to each other, are equivalent to the hypotenuse of that triangle. So let's do that for this vector. Let's make this vector that we want to resolve, meaning we want to split it up into horizontal and vertical components. Let's make it the hypotenuse of a triangle. Okay, so this vector, which is the vector that I'm concerned with, I can break that up into its horizontal component, and I can break that up into its vertical component. Right, so I'm just going to call it F Y, because the y-axis is associated with being vertical, and F X. And now let me apply basic trigonometry to it. So let's start with cos. Alright, so cos theta is given by adjacent over the hypotenuse. So what's adjacent to the angle? Well, that is my horizontal component. And what is my hypotenuse? Well, that's the vector that I started off with. That's F. And if I rearrange the subject of the formula to make f of x the subject of the formula, I realize that f of x is equal to f cos theta. So I can work out the horizontal component if I knew my angle and I knew the value of the vector that I'm trying to resolve in the first place. So continuing in that vein, then sine theta is opposite over hypotenuse. So what is the opposite to the angle? That's f of y all over the hypotenuse, which is f. And if I make f of y the subject of the formula, because that's what I'm trying to find, right? I'm trying to find the vertical component. So if I make f of y the subject of the formula, that is f multiplied by sine theta. So I have now these expressions that are based on my diagram of how to find the components. So naturally we will do some questions with some numbers and hopefully it'll click for you really easily, but what I wanted to show you is that there's another way to draw this diagram. I don't have to draw it so that it's shaped like a triangle. If you want to, that's fine. But what you could also do is I can draw this vertical component. I can draw it starting from this point over here as well. So what that would look like is this is the same vector f, right? And I can draw my horizontal component acting this way. So this is still f of x. And instead of drawing f of y this way, I can draw it from this side over here. F of y. And I personally prefer this approach because it shows to me that f is, you know, this is the resultant of these two. So if you had these two forces acting, they would give you the same as if f alone is acting. So visually, I prefer this method. You don't have to. Visually, you may prefer this method because it's easier for you to see the triangle and understand when to use sine, when to use cos. But they're both the same is the point that I'm trying to make, right? So let's get into a question with numbers and put this to use.